This is Rges Pre-Algebra. Welcome to Lesson 1.18, Complex Fractions. Now, complex fractions are actually, they look scary. They look complex, but they really are a fairly easy concept. So the definition of a complex fraction, let's say I have a normal fraction, I maybe would have 2/3. That would be a simple fraction. A complex fraction would either take the numerator, and that itself would be a fraction, okay, or the denominator would look like a fraction, or they would both look like a fraction. Something like that. And admittedly, this, and this look rather intimidating to us. But it is not at all if we'll remember one simple thing, and that is that a fraction means divide. Okay? This means divide, this bar means divide, and this bar right here means divide. So I can take this fraction and rewrite it as 2/3 divided by 3. Well, you know how to do that. That is the same as 2/3 times reciprocal, which is 2/9. And so I've taken something that looks very scary and I've made it really quite simple. Let's look at the next one. If I have the problem 2/2, I'm going to rewrite that as 2 divided by 2/3. I'm going to convert my division to a multiplication by the reciprocal, which is 3/2. Okay. Remember, this is the same as 2/1. If you need to write that in there, you're going to multiply straight across. Actually, I'm going to cancel first, and I'm going to get 3/1, or 3. And finally, the last one here says 2/3 divided by 5/7. 2/3 divided by 5/7. Written as a complex fraction, but that's okay. I won't let it intimidate me. I'm going to convert it to writing it as a division. 2/3 divided by 5/7. That is the same as to multiply by the reciprocal, 2/3 times 7/5. In this case, nothing cancels, so not so much fun for me, but this is 2 times 7, or 14, 3 times 5, 15. Nothing to simplify there, and that is your answer. Now, for the next part of this tape, I'd like to go to the problem-solving strategies. If you would get out your textbook and look at page 25. So if you've come back and you've got your textbook, we have a recipe for chocolate chip cookies on the right-hand side of the page. And on the left-hand side, it says, the 36 members of the math club are planning a party. Chloe plans to bring her special cookies. She wants to have 2 cookies per member. She knows she has plenty of each ingredient except chocolate chips. How many ounces of chocolate chips does she need? Well, this is a multi-step problem, so you want to just pause and think about it a minute. Okay, what do we have? We have 36 students. We want 2 cookies each. To get the number of cookies, okay, and that would be 72 cookies. Now, my recipe makes how many? So that's part 1. My recipe makes how many cookies? It makes 48 cookies. So do I need to make the recipe more than once or less than once? Well, it only makes 48. That's less than 72. So I need to make the recipe more than one time, right? Okay, now my question is, what portion or what proportion is there between the number of cookies I need and the number of cookies the recipe makes? Okay. Sometimes it's hard to tell what operation. For a student, it would be hard to tell what operation I need to do next. I know that I need 72 cookies, and I know that it makes 48 cookies. But I need to understand, so what do I multiply my recipe by or divide it by to get the proper number of cookies? Okay, let me give you a couple examples. Needed and made. Let's say I need 10 cookies, and my recipe makes 20 cookies. What do I need to do? No pun intended here. Okay, I need to take the number made, right? Or let me say it better this way. I need 10. It makes 20, so I don't need to make the whole recipe. I need to make 10 out of 20, or 1/2 recipe. So I think this illustrates, I'm sorry, that's a C, C-I-P-E. Okay. Let's do another example. The needed and the number the recipe makes. Let's say I need 10 cookies, but the recipe only makes 5 cookies. Put the number needed over the number that it makes. And in this case, I would need to double the recipe, or do 2 times the recipe. Okay. It is often helpful when you're thinking through word problems, and the reason I'm breaking this out is so that you can always go back to something obvious to you. Well, it's obvious to me that if I need 10 and the recipe only makes 5, that I need to do it twice. Or if I need 10 and the recipe makes 20, I only need to make half the recipe. So go back to what you know and understand by making a simple problem, and then use that for the problem they give you. So in this case, what's my pattern? I take the number needed over the number that is made per recipe. Okay, the number needed is 72 divided by 48. Well, I want to simplify this. So I see that 8 goes into both those numbers. 72 divided by 8 is 9. 48 divided by 8 is 6. I have not reduced it all the way yet, but I can also now divide both of these by 3, and this gives me 3 halves. I need to make 3 halves, or 1.5 times the recipe. Okay, so that would be part 2. My multiplier. What is my multiplier by the recipe to get the exact number of cookies I need? Okay. And then the third question would be, therefore, how many chocolate chips do I need? Well, for one recipe, for a single recipe, I need 12 ounces, but I need to not double the recipe, but make 1.5 times the recipe. I'm going to use my fractions. I would have preferred to do this and not converted it to that. That's just easier maybe for you to think about, but not for you to do your math. So we're going to go back and use that. We're going to go 12, the number of chocolate chips, times 3 halves. 2 goes into 12, 6 times, and 6 times 3, I need 18 ounces of chocolate chips in all. Next idea is going to be found in the 2 additional word problems on the next page. It says Chloe has only one cookie sheet. It holds 15 cookies. How many times will it take to bake the 72 cookies? Well, that's pretty straightforward. I would take the 72 cookies that I need to make, divided by 15 for each sheet. And I'm going to come up with 4 would be 40, 60. Subtract, and this would be 8, 4.8. 80 and 40 more is 120. Now, I can't do a 0.8 part of a cookie sheet, so this illustrates something else we need to care about, and that is making sure my answer makes sense. So if it really takes 4.8, so it means that the last cookie sheet will not be filled. Nevertheless, it asks how many times will I have to bake them, and that will be 5 times, even though the last cookie sheet is not filled. And then finally, the last question would be number 2. It takes Chloe 10 minutes to mix the ingredients, 3 minutes to fill the pan, 1 minute to take them off the pan. How long would it take, should she allow to bake the cookies? Okay, so we've got mixing, and that's 10. We've got filling, and that's 3, but I'm doing it 5 times for the 5 sheets we just discovered in the problem above. 1 minute to take them off, but again, that 1 minute has to be done 5 times. I could technically argue the last one's a little shorter, so it might be a little shorter, but we're not going to do that. And then finally, I also have to bake the cookies. So what does it take? Well, look at the recipe. The recipe says it takes 12 minutes per sheet, and I have 5 sheets. So that would look like 10 plus 15 plus 5 plus 60. Now, since I'm looking at time, this is going to be 1 hour. And so let's add up the rest. 10, 25, 30. So 1 hour and 30 minutes. Or 1.5 hours would be my answer there.